Hi, this is James from Stealth. Today I'm happy to announce the launch of public testnet for quantum proof of stake. Quantum proof of stake is a technology we've been developing here at Stealth that allows for 5-second block times. Compare those to Bitcoin at 10 minutes, and very regular 5-second block times that can combine with cryptographically private transactions. And what we mean by private is it hides the sender, the recipient, and the amount of the transaction. Before I start, I'll just talk about our testnet here. Our website. Our website is stealth.org, and it's listed up here and way down on the bottom of the tagline, stealth.org. You can go there and read about quantum proof of stake, find our roadmap, our white paper, and the section that I think is the most useful to me, at least, is our news and development blog, where we post links to our development blog and any press releases and important news we have going out. Today's video will be embedded into a blog, and we will use that link to that will go up here just like all these others. So pardon the scrolling and stuff. It's formatted for like a tablet widescreen and not very big, so the video's not too huge to download or stream. So the first thing I want to talk about with the public testnet is, what do you need to run public testnet? Who is this video directed to? This video is directed mostly to people who want to participate in the testnet, who will be who, once quantum proof of stake is launched in the future, will participate in that in some way, either as a block validator owning a stealth node, or as somebody running a third-party service, or just an aficionado who likes to play around with blockchain and thinks that the quantum proof of stake is something of interest to them. There are lots of different consensus protocols out there. Quantum proof of stake is one of them. We think it's a good one, and it may appeal to some people who are interested in blockchain, and other consensus mechanisms may appeal to other people, but we think this one is pretty good. Certainly has fast blocks and has some cool features not found anywhere else. But today I'm not going to talk about the technology so much as how to use it, and how to use it comes down to what equipment you use. In this case, what is your virtual machine you're going to use? What are the specifications for what I consider a type of virtual private server, or VPS, that may perform pretty well with this blockchain, with quantum proof of stake? And I think this offering from DigitalOcean, from their dedicated CPU line, CPU optimized with 4 gigabytes. This is the lowest CPU optimized VPS that DigitalOcean offers. It has 4 gigabytes of memory, 2 dedicated virtual CPU cores. So it's a dedicated CPU with 2 dedicated virtual CPUs. That means you're not sharing with anybody. There's no latency related to their process getting done and your process starting. And so this helps with processing transactions on the blockchain a lot more efficiently. The reason for 2 vCPUs is that operating systems have their own sort of housekeeping processes that come on from time to time, say disk drive indices and so forth. You don't want to be waiting on one of those while it's your turn to process a transaction or a block or download a block or something like that. So that second core is really going to help. 4 terabytes of transfer. This is a good number. I've never really ran into a bandwidth issue for VPSs, and I've used the VPSs considerably over the years doing cryptocurrencies. Then the hard drive space is 25 gigs. You want about 10 gigs free. The OS I think is about 8 gigs. You know, a Linux OS like Ubuntu, stripped of all of the graphical stuff, is about 8 gigs. And so on top of that, you want about 10 gigs. The reason for that is if you're running a node in the testnet, you're going after the earnings. You're actually in competition with others to earn stealth, and you want to add first some debugging output into your log file by turning on some debugging options. And when you do that, your log file can get rather large. You don't want to run into a log file issue where you've filled up your hard drive and then your node stops and you miss earnings for a day or something. The price here is about $40 a month. DigitalOcean is a name brand. Everybody knows the Droplet who uses VPSs. They know of this option. So it's a name brand. It's kind of famous. The price is going to be a little bit higher. They have excellent service. From what I can tell, they've always had excellent VPSs that I've been able to rent. And if you compare this to what your earnings could be on the testnet, there's 21 testnetters. For each testnet operator, there's 10,000 stealth of reward pool. That equals a total of 210,000 stealth. 210,000 stealth divided by 21 is 10,000, of course. Each stealth is cost 6 cents right now on the blockchain, on the exchange, on Bitrex. And so if you do average, you're going to make about $600 in stealth at the spot price, of course. If you dump it all at once, you may get a little less. Compare that to, say, running this node, $40 a month for, say, a 3-month run of the testnet. That's $120. The difference is $480 of profit. So in my opinion, it's worth spending a little extra to get that performance improvement. And that could be the difference right there. Like if you want to save $60 but you're out for a few days or something, you don't realize it, that's going to cut into your earnings. So you may want to have a pretty well equipped VPS node for this, or you may not. Take your chances, or make some sacrifice for earnings for whatever you can afford or something. But that would be my take, is just pay a little extra and try to get those earnings, try to make it back on the earnings side. Once you get your VPS, then you're going to get an email from them or something with a password, and so you want to log in. Okay, so I'm going to log into mine. Right now I'm in a testnet node called T3 that I've been using, and I'm going to come in from this one. Okay, so I was just looking to see this was the right one. Yes, it is. So I just secure shell in. This is at 157.230.182. This one I set up here, and I've got a passphrase. If I can remember it. Okay, so this is what you might look at whenever you log into that server for the first time. So the first thing you want to do is harden it. You want to harden your node. And the way you do that is you edit. The very first thing you do is you get your secure shell environment ready for your account. So the way I do that, the first thing I do is I type SSH keygen. This might be very well the very first command I type. And I don't really actually want to make a key here. I just want to, this makes a directory. called SSH, .ssh in my home directory. It's a hidden, that's what the dot means, and it has these permissions here. So it has the right permissions. This is the line. If you're not a Unix guru, you may want to know this. Anyway, this is the line that says the permissions for this directory. And in this directory goes this file called authorized keys. So this file is already filled out, but see, the commands I use is called VI. So that's my editor. There's another editor called Pico. I'm guessing most people aren't going to use VI. Some people might use Emacs. I've never used Emacs. Most people use Pico or I believe Nano, but Pico is usually the one people go to. And I think you can start typing in here. Okay, so if you, I'm just going to control exit. No, okay. On your local machine, okay, so there's a local machine and a remote machine. Local is the machine you're sitting at. Like you're at home, you're at your table, you bust open your laptop, you start watching YouTube. That's a local machine. You take your laptop, you open up a terminal program, or in Windows, you open up the shell, and or PuTTY or something, and you're going in and you're working on the machine that's far away. That's the remote machine. So local would be your laptop, YouTube, Facebook, terminal, typing commands somewhere. And then the terminal goes to, you type SSH or use PuTTY, then that goes to the remote machine. So local and remote. So the first thing you want to do is on your local machine generate these keys like I did here. Okay, but whereas I just skip the passphrase step, you want to set a passphrase because it's add security and a good one, and that just protects your private key on your local machine. Needs to be a good passphrase. Then you take that and this just spits out, cat is a Unix command that spits out the context of a file, id rsa.pub. Oops, that's in this directory called .ssh. Directories are like file folders, you know, in Windows or Mac, file folder, and there's files in it. That's what so in Unix, that's called a directory. And this is going to have this form here. This is an RSA type SSH key, and that's the user at the end. So you copy this. It's wrapping around, but it's still going to copy all as one line. These ends over here don't register as aren't copied as line returns or anything. So .ssh. Okay, this just pretend this is, I don't have the not here. So then I just paste it in there. Let's see, the whole thing didn't paste. I must have highlighted some. Oh, it did. Okay, I'm not used to this one. So let's just exit. So let's pretend you know how to use Pico a lot better than me. I'm going to do so when I paste that in there, see, it looks right. On Pico, it never wrapped, okay? If you use Pico, you're on your own. I use VI. Editors are like a strange thing because they all kind of work a little differently, so people get attached to this one or that one. So then that just goes right into this file. It doesn't go into a file called not authorized keys. It goes into a file called authorized keys, but I already have that file filled out and I don't want to mess with it. So just when you type your command, don't put this in. Don't put that not dash. Just put in authorized keys as it is spelled here. So now you can get in through your remote machine. Okay, I've already edited my authorized keys. Now you need to harden your etc.ssh. Oops, not .ssh. sshd config. Here, you want to get rid of password authentication. So when this file, I've already edited this one because this is the first thing I do. Before I even make the video, I'm going to do this, right? But this is how it comes. Password authentication, yes. Okay. change that to no. That's the most important thing you can do to harden a computer, because it just disallows people to guess a password. Instead, they have to guess private keys, which they're way more complicated and difficult, as you can imagine, to guess than passwords. So here I quit. Well, there's a couple of more things you want to do to make your life better. Almost forgot to bring these up. So the first thing I do is I set these client alive stuff. Okay, I don't remember how this file came, but you want these 3 lines right here. And don't worry, I'm gonna write this stuff out. I'm gonna go watch this video again myself. I'm gonna type the commands out as we go and not make a full transcript of the video, but do a good job to where there are instructions in the blog post. I take these commands and I put them in. Client alive interval 120. I make sure this is uncommented. Yo, whoa, hey, what's a comment? A comment is this hashtag. That's what they call them these days, a hashtag. A comment has that in front. See how it's a different color? These are not commented, so you delete this. So you delete the hashtag, and you add all these lines in there. And the hashtag is here in this file. In case anybody's curious, this is the default setting. Use login? No. GSSAPI authentication? No. I don't even know what that means. But these are the ones you put in here. Okay, client alive interval, TCP, client alive count max. This means that when you secure shell in, then you don't have to worry about the connection getting reset by the remote host. Remember, remote was a computer that's far away from you, that you're not sitting in front of. When that's reset, then you have to log back in. If you're in the middle of editing something, just to go get a cup of tea, you lose your place, it wasn't saved, it can suck. So you want these connections to stay open. Should you save your files every like 5 minutes habitually? Yeah. But does anybody? No. I mean, very few people do. I do when I'm really in the groove, but that's sometimes I can forget for many hours and have a disaster. So that's not uncommon. So those are the main things. Typically, I would make a different user if it was if this weren't Testnet. I would actually make a different user and set all this up as that user that's not root for that extra layer of security. But this is the extra layer of security. And now I want to restart SSH. And the way this is typed in Ubuntu, which is the one I'm using, service SSH restart. So I recommend Ubuntu 18. That's what I am installing these days, and I make sure Stealth will run on Ubuntu 18. So I just restart that service, and so those new settings should take effect. I should be able to just log right in. That's the password for my private key on the machine I'm coming in from. And here we are. We're there. Okay, so now we've done kind of the hard part. So the first thing you see here is there's some app packages that need to be updates. 2 of them are security updates. Oh my gosh. So let's get those installed. So get update. Okay, for Ubuntu, that's how you do it. We're just assuming Ubuntu here. If you want to do it, if you're like, hate Ubuntu because maybe the name is stupid or something, and you want to do CentOS or something cool that your friends are all using, then you're going to have to find the correct commands. This is for Ubuntu. Apt get upgrade. This should also work for Debian as well, and other variants like Mint. I found Ubuntu to actually, even though it may have the worst name and may be associated with people who aren't super nerds, because like actual regular people can use Ubuntu. Even though all that is true, it's really a great version of the Linux operating system. I mean, I use it everywhere. exclusively pretty much, unless if I have to run like CentOS on something. Okay, this is asking me for all to keep all my current settings and stuff. I guess I changed them at some point. I have no idea. I take all the defaults. When that just came up and went away, I just hit return. And return, when those peak screens came up, I just hit enter, return, whatever, however it's listed on your computer. Now we've upgraded. I like to do the dist upgrade. It usually gets some extra packages. Now look at all this stuff here, all this Linux generic stuff. These are just different, as the kernel has been upgraded over time, with these become obsolete. So this last little update I did made all these files obsolete. You don't want those building up. At least I don't like them building up. In some cases, they're not actually benign. They'll fill up your boot, a little bitty partition called your boot drive, and your computer will complain about it. And you know, when a computer complains, we got to type in some commands and stuff. Yes, it does take a couple of minutes. And again, it's this, I'm just hitting enter or return, however it's listed on your computer. Here's another one. Great, sure. Yes, 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 and yes, yes. Think? No. Hit enter? Yes. No thinking? Hit enter. Enter. Okay. Then I can just reboot. I would type sudo here because I'm used to typing that, but I have to fix the host name on this computer. I just hacked it to T5 for this video, and so it doesn't like me entering sudo, but I'll just not do that. So the command is reboot, and I like to do that whenever I upgrade. I believe it's necessary. It boots into the new kernel, which could have some security improvements in it. If you're like me and you keep up with a lot of security news, first you'd be terrified. You'd be absolutely fetal every day at the number of exploits and vulnerabilities out there in the stuff you use every day. And second, you'd reboot after you did an upgrade on your OS, which is, if you want to get anything done, the fetal position is not typically an option. So I go with rebooting. Okay, so here you go. Now we're all upgraded. Now what do we do? Well, we have to install the dependencies. Okay. Now, fortunately, on GitHub, if I can find the correct program here, I've got it in Safari, so I don't bring up my other browser, so I'm not used to looking for that icon. In our wiki, if you go to our wiki, the very first page you see is how to build the daemon. Isn't that beautiful? Oh, here's something I forgot to do. So first begin with yada yada yada. This can be 1604 or 18 or the newest 18. Oh, and I mentioned OVH. OVH is where has been used as a hosting provider by so many people, and I believe they are still happy to take customers that will run cryptocurrency daemons, as long as you're not like trying to mine on their VPS, on their VPSs. I think they'll take your business. And this right here, okay, if you're I use the US localgen. It doesn't typically matter except if you don't want to listen to these little warnings and stuff. So I just copy. I'm waiting for my hard drive to spin up. I must have got, I don't know why it's doing that, but anyway, I've got a backup drive hooked up to this computer that I'm going to eject. That I want to eject, but I'll do it later. So I just did that. That will prevent a lot of errors and stuff that you don't want to look at, that can be confusing. Then there's all these commands. Hey, I just did all these. Great. It says you will get logged out here. Just log back in. Now install everything except BDB and libevent. Okay. For some reason, you have to do all this and then install lib event. Okay. Let's switch to terminal. I'm just typing those in. Now, what's going to happen here? Let me take out the sudo because it's going to complain. What's going to happen here is it's going to basically say everything's all installed already. It's putting in pzip full because I guess that's a new dependency or something, or I may have just added it. Now, if you would have typed in this command on a fresh server, it would just be sitting here churning forever. But obviously, we can't wait for that. I'm so socially defunct, I would make you wait for that, you know, because that's just how I am. Actually, I'm not like that. Okay, so let's see. Go back over here. Now you got to build your database. This is the database for the wallet. This goes back to an ancient version of the Berkeley database that is compatible with the original Bitcoin code that was built against, and it's never changed. And you will, I've never had a problem just installing it, and it works just fine. I guess there were no bugs in this version. But there's a bunch of commands. So now I'm going to run all these to where notice I'm using wget. What these commands are doing, on this part you don't have to really, it's just copy paste. Okay, so you're witnessing the copy and the paste. And we're using this command here, wget, to download the source code. Right here, wget. And it was installed when we did sudo apt-get install. Or if your sudo is broken, like mine, you just do apt-get install. So cd make dir, which is make a directory in my home folder, which is that tilde. Tilde is a squiggly line. It's called deps for dependencies and BDB for Berkeley database. I've changed to that directory. I'm working inside that directory. You can imagine that like you open a file folder and it's got a bunch of files in it and you're shuffling and you're writing things on them. It's that same concept, okay? And then you close the file folder and you open another one. You're working in that file on that file folder in that directory. So now I'm working in the directory deps BDB, and you just hit enter. And it downloaded already. You're like, wow, that was fast. It's not that big. 21.7 megabytes from Oracle, whose reputation depends on performance. Yeah, you're not going to have to wait too long. Now, next command to copy paste. What this does right here, this command, which you can't see the entirety of for some reason here. Oh, because the window is kind of scrunched. This command just reads this file, and notice this is a DigitalOcean, and it's doing this stuff pretty fast. So I'm using a DigitalOcean droplet. I think it's not those same stats. So it's a cheaper version. It's not a dedicated CPU, but this is just for the purposes of this video. So it just checks to make sure that this file is in good shape, using a cryptographic hash. And everybody, yeah, I don't have to explain to anybody watching this video what a cryptographic hash is, because y'all all own cryptocurrencies or are interested. And if you don't, you're knowledgeable enough about cryptocurrencies to know what a cryptographic hash is, so that you could be an educated critic thereof. All the critics of cryptocurrencies are cryptography experts. They don't tell you, even though they come across as not knowing anything on Twitter and other social media, they're all cryptography experts. That's what gives them license to criticize the technology as they do. So we've checked the file out. Do y'all like my commentaries? I guess I'm in some kind of mood today. Okay, so not enough sleep, I think. So now we're going to unpack the file unpack the archive into individual files. Tar means tar archive. Then we're going to change into that directory where we're going to build, and then run this command to configure the build, which the details of all that I'm not really going into. That was fast, and the config is going to be pretty fast too. These DigitalOcean droplets are, this isn't supposed to be an ad for DigitalOcean, but I think they're pretty good. I don't really complain. They're almost as fast as a desktop, Okay, now I just configured. I'm going to make with both cores. I believe this is a 2-core. I just don't remember. In fact, let's just see what happens. Sometimes it'll crash because I may not have the 4 gigabytes. I think I don't remember what kind of droplet this is. I made it a long time ago, and I just searched for something that was hardly being used and stopped the processes on it. I was running a wallet and I just killed the wallet. Okay, so what I did there is I built it. Thank you, DigitalOcean, for that speedy build. And then I'm just installing it. Now it's all installed. So now we've installed a lot of stuff. I'm just going right through here, copying and pasting. And so now I have to install libevent. Why I have to do it in this order, I don't know. But from experience, it does not work in a different order. Already installed. Did y'all catch that? It's already installed. Okay. Oh, that's what happens. I try to click here. And then here we go. Now, I'm not going to go all the way through here. This is how to build. I'll change the instructions for how to build the testnet, the quantum proof of stake testnet node. They're just slightly different from here. So if you're following along, copying and pasting while you're watching YouTube, just when you get to here, don't copy this part. Well, you could actually copy. Let's just do it. Let's copy this part. You can copy this part all the way through. So it's a nice block. You can copy the whole block. Ignore what I just said because this doesn't really matter. Conceptually, it kind of matters, but technically it doesn't. Okay, so now we clone from GitHub the full stealth repository, but we are on, I think this is the command, we are on the master branch. Is that the master branch? That's a good branch to be on, the master. But we want to be on a different branch. Git checkout. I believe this has to download some stuff, but QPoS 3.0. Okay, so this, instruction, it's not here. Notice how it's not here. Not get. That's what they call a typo. So now I've switched over. Now it says, now if I do git branch, it'll say I'm on QPoS 3.0. That's sweet. Okay, this next thing, I may edit the video, I may not. Make minus J2 minus F. I should have already had this done, shouldn't I have? Because this is going to take a few minutes. We're going to find an expert and splice this video together because I don't want to make anybody wait through this. It should be pretty fast, but here we go. I'll just let it go and see if I can splice this video later. I must be able to. What is it doing now? Maybe, oh, you know what I could do? I could talk about something. What can I talk about? So after you build a client, you're going to run commands. Oh, that's what I can talk about. Let's go here. Help. So this is all the commands that this is all the commands that are related that have QPoS in it. How about staker? Yeah, specific to stakers. Oh, here we go. Yeah, that's the one we want. All right, let's look at these commands. I'm going to cover up this distraction in the background. I'm going to move this over. And I'll just kind of guess when it's done. We'll go all the way over here with this baby. Okay, so look at these commands. We'll go over them. They're not in an order, actually. So what are these commands? There's documentation. This one's called claim QPoS balance. That's where you claim a balance. You earn block rewards when you sign blocks as a stealth node operator. Also called a staker here because that was the original name and it's shorter. So I kept it for the shortness. When you earn on the blockchain as a stealth node operator, those coins are not spendable in the typical way. You have to claim them, and when you claim them, you can't spend them in the claim the way it's designed at this moment. You claim them by proving an authority to claim the balance. So, anything that has a get in front of it is informational. Notice how they're all informational. Anything that doesn't have a get has, so get QPoS balance. Quiz, is that informational? Yes. Get QPoS info. Yes. Informational. Get staker ID informational. Get staker info informational. So it's pretty much it's 100% consistent. If it has get, it's informational. All other transactions will do something. For example, claim QPoS balance claims a balance. It moves it over to a spendable, what's known as a spendable output. But everyone that doesn't have get, and I guess I should, if I really knew how to do it, I could just list those out. Every command that's related to stakers and quantum proof of stake that doesn't have get has, does everybody see the commonality? TXID and VOUT. And this may seem very strange. Like, what are those? Okay, that's a good question. So here I'm going to list transactions. And I do recognize this address because I've been playing with the Stealth Testnet for so long. I'm beginning to recognize addresses and stuff. I should wish if I could recognize this public key, then that's the TXID. This is a transaction output right here, and this address has 16.657 in this transaction output. I did this in another video, but I just want to do it in context of this instructional video. It says 2 confirmations. Oh, because these are staking confirmations. I'm like, why? Why does this thing have this 2 confirmations? It's still proof of stake. The network is going to be proof of stake for a few days here. So this, as I mentioned previously, and as all the Bitcoin critics totally understand, this is actually a representation of a public key. Oops, that's one word. Validate address and give it the address. When you do that, you can see the public key that this address corresponds to. So the address is a representation of public key, and for the Bitcoin critics out there, what it is a 20-byte cryptographic hash of the public key with a network byte placed in front, and then encoded as base 54, which is a ASCII character based encoding that can be easily read, copied, and pasted by humans. I didn't have to say that for most people, I'm sure. And that's what an address is. But it corresponds from a public key. From the public key, you can get the address, but with the address, you can't get the public key unless if like it belongs to you, or you can see it in the blockchain. If it belongs to you, you have an entry that holds your public keys and can derive addresses from them. On the blockchain, if you just see an address, you don't know what the public key is because you don't know the 20-byte cryptographic hash, unless if the public key has been used before, and it is, you know, if it's been used before, you can calculate all such public keys, encodings, and find the address. So that public key, if you, the point I made in the previous video is if you can spend this coin here that is at this address, then you have proven that you can you have the private key that correlates to this public key. So private key and public key are a pair. Public key is a one-way function to get the address. The funds are sent to an address, and if you prove that you have spending of the public key, which means you have spending authority over the private key, which means you know the private key. Let me say that again. If you prove you have spending authority for the address, then you've proven spending authority to the pub key, which you have to provide the pub key whenever you spend the funds. And that proves you have spending authority over the private key. So anything to this public key, if you can spend something to that address, then you've proven authority of the public key. I just said that in like 25 different ways. Hopefully it sunk in. Going back to our commands here, and also the other one, which was claim QPoS balance. Each has a TX ID and a V out. Well, if you look at this transaction, so this is stealth coin get transaction. The TX ID is here. This is the V out, even though it says N. That's the V out. Okay, I didn't make this system. But see, oh, well, here's the V out. Which V out number is it? Oh, 1, 2. This was a staking transaction. So the value here, actually, this has two outputs. The net earnings was 16.67. That's where this number comes from. And this output right here, output 1, is 666,166 stealth, testnet stealth, not real stealth, that you can spend. So if you can spend this output, you've proven you can spend from this address. You've proven you can spend from the public key, and that is what you're supplying here. So let's check out help crypt staker. Let's just see this right here. So this is a short one. This is like the minimum. So disable staker or enable staker, transaction ID and V out and alias. So with these three things, the protocol knows which staker you want to disable or enable, or which staker you want to set a key for, or set some meta information for, or extensible attributes. Instead of meta information, extensible attributes is what we call them. If you know the TX ID and the V out. So what you do with that, so the TX ID and the V out specify, remember, an address. That address is correlated with a pub key. Right? It's derived from a pub key. Let's look at QPoS info. You own a staker. Let's see. Yeah. You own a staker. Say this guy. There's an owner key, a pub key. Pub key O2B2EA. pub key O2B2EA, address for that pub key, MYRPUGOY. See? So if you can spend to that MYR address that I just set up here, then that means you have this authority associated with that. How do you prove that? Well, you just spend it. Could you sign something? Yes, but I believe in the most simplest systems possible. Let's say you want to disable a staker. Okay, disable staker, then you have to put the public key. Let's imagine we're not spending something as proof. We're just making a signature. Then the command would look like this. This isn't really a command. That's for people who may not get it. Okay, you want to enable, let's do enable staker. Enable staker. Okay, I got to put my pub key here. Oh yeah, yeah, that was this. Okay, you're still gonna have to look stuff up. Then whatever you're gonna sign, statement. Can't do an apostrophe there, so we'll just leave that out of the contraction. Signing. You have to sign something. Okay, great. Statement. Then you got to put the signature in. How long is the signature? It's 37. They're like 30. I can't remember how long they are. We can look it up. They're pretty long. Okay, there's a signature in here somewhere. When you do this, yeah, the script pub key. Something like this. It's a bunch of bytes. I think I can't remember how long it is. So it's basically you would have to do this anyway, because what does this has? This has the pub key that you're signing, and you're signing the transaction, and then you're also gonna have to do this in this last bunch of bytes here, whatever it is. I think it's 31 bytes or something. I can't remember. So it'd be 62 characters. I can't really remember. Those would have to go here anyway. You'd have to put the signature here anyway. So why not just cut? And then you have to have a fee for all this. So you'd still have to say, you still have to let it do a fee. I guess you wouldn't have to specify that, but you still have to look up and specify a bunch of stuff and create a signature. I guess you wouldn't have to do this, and it could generate something you're signing, but you still have to put the public key, and you'd still have to put the staker thing. But what I do is, and then it's still going to have a fee, and it's also all this extra information that you're going to have there anyway, because you've got to sign this transaction. It's going to add to the blockchain. So I just don't like those ideas where you're adding stuff to the blockchain and it isn't necessary. So here I just have enable staker, what output you're going to spend, right? This identified the output. This transaction. Pretend that this output to this transaction. So that transaction ID and that value 1. And if you can spend to this address, it will generate a signature on its own. So remember this here, that wasn't a real command. That's not the form. This is the right one. So you enable it. You just say what you're going to spend, and then it's got to have enough funds for a fee. So you can just send some fee. So you don't have to have a special extra info in the transaction. Then where are you going to put all this stuff in the transaction? It's going to exceed 140 bytes, maybe. And then, yeah, it's going to exceed 140 bytes because you have to have the signature in there too, I think, and the name of the alias and all that, name of the staker. So it's just what staker are you enabling and disabling. So what are you spending? What enable are you disabling, enabling, or whatever, what staker? And then it just gets spent and the fee gets generated. It's nice, it's sweet, it's compact. That's how I do it. And that's how it works. And if that sounds complicated, remember, you're going to be running a node for profit, right? So you might have to know something to do that. I don't the jobs out there where there's no expertise required, they don't actually pay very well. You know, I don't know if I think when I was a kid, I got a job in a restaurant washing dishes. I did have to learn how to wash dishes, how to operate the dishwasher and stuff. Um, but the upfront knowledge was kind of a command of the English language, minimal. So there wasn't really much to know. But, in my kid state of ignorance, I didn't earn that much money. Okay, so let's see here. The lectures are for people who complain. They do in blockchain. They complain a lot, so we have to head them off. Okay, so but they're welcome. They're welcome. Just learn, guys. It's good. Helps everybody. We should be done building by now. Let me slide that over. Yes. So what I do is this isn't part of the build file, but I just do it out of habit. I strip it. Strip the node. And believe it or not, you're ready to start your node. Okay, now what you have to do actually is on the first, you have to run it the first time. Okay, yeah, you have to configure this node. Okay, it complains. It crashes, it complains. Some clients just keep going and they don't tell you the stuff. I mean, I don't mind restarting it again because exactly what this file is called, I don't memorize things so well. So even for this coin, I mean, if I didn't use this every day, it would be a huge. I would still have to look it up in the code somewhere or try to find in Telegram or somewhere what the stupid conf is called. This is called a conf configuration file. What this is called when you can just it can just tell you. So I actually like that. So VI that you can use Pico, and I'm showing you this. So this is generated different random every time. This is completely random using a random source of entropy. On Unix. On Windows, it'll probably give you something that has like really horrible level of security randomness, but I don't use Windows. No, maybe it's really good. I don't really know. But you need to add some other stuff to it. Okay. Oh, not that. Stop. There's some other stuff you need to add. And I'm going to put this stuff up. This is not edited at all. Okay, so well, I'm not going to reuse the password. This is a testnet, so I don't really care if people see my password. But whoops, I did not want to remove that. Yes. Okay, so server 1. 1 is true, 1 is yes, and 0 is no to computers. Computers are better with numbers than letters because they're machines. So typically, you use 1 and 0. We yield to our stealth node master's preferences. Then there's a few debugging options. You don't have to turn on the basic debugging, which will give a lot of output, but this coin is debugged at that level. Then there's something called debug net, and this one debug net is an option that helps me debug the network, basically block transfer type stuff. Debug QPoS, that should be obvious. That's a bunch of stuff. And then this one's critical. So I would like all these to be on. It'll help everybody. You, me, you know, can I see your log file? These are going to spit out a lot of stuff. It's going to make some pretty big log files, but that will help me debug stuff. Those two are kind of critical. The debug option doesn't even have to be there at 0. It's not terribly necessary. Then you don't need to add these. These are seed nodes. These are the nodes I was using when I was running this on ClearNet, where the network tends to operate a little bit better. And then there's these two, stake and staking. You can just, let's get rid of those. Those are, I'm running the stakers, and I'm running staking nodes, standard, old school, what I call King Nadal proof of stake, the regular proof of stake that was originally invented in Purecoin. Then this is actually for quantum proof of stake. Please put this in. It's rollback dead end. Okay, so there are dead end chains, and on the testnet, typically we probably won't have to do this whenever we have a full testnet. We can get people to turn these off and just see what happens. You don't need to roll back. I mean, you want to roll back when you hit a dead end chain, but here it will get confused as to what a dead end chain is because the network is small and nodes. And the way I was testing, nodes would get disconnected, and then if they got disconnected, they would just stop block production. The whole testnet would stop. I don't anticipate this happening on the public testnet because we're going to have 21 operators, which is like a great number. There's going to be a lot of nodes, a lot of connections. People are going to be having certified nodes, so the core network is going to be very well connected. I don't anticipate this, but to start your original version of this file should have rollback dead end equals 0. The default is 1, so you have to specify it. And what I'm going to do is, these were basically for my records here, so I'm going to delete all these. You definitely do not want only net. So this is what you want. I'll copy paste. So wow, I really trimmed it down. You of course want your own RPC password, you know, especially on mainnet. Oops, why didn't it? Can't open file for writing. That doesn't sound good. I'm going to copy and paste. If it does it again, I'm not going to know what's going on. I bet it has to do with my host name. Let's see. What can I do here? This isn't good. I don't want to change my host name. Back. I will. Okay. This is going to reveal. This can. I was running a cannabis coin wallet, guys. Fortunately, that's not illegal. Smoking cannabis, but hey, I was trying to keep that a secret. Okay, now you know. I didn't need the cannabis coin wallet. I saw the coins, but it's proof of work. Okay, it's DigitalOcean, so reboots pretty fast. Coin.conf. Please, I hope I didn't copy anything else. That should work. Okay. Okay, so I wanted to name it T5, and then I just wanted to get this video made. So I didn't go and change the host name wherever else it had to be changed. So now we're back at CAN. CANN for cannabis coin. Is it a good coin? Seems to work. So that's everything you need. I'll copy and paste that except for the RPC password, which you will get whenever you run it the first time. Now we're ready to go. Oh, so I built this. What I do here, remember we built in source a long time ago. I forgot to do this part, and I'll watch a video and make commands. So see, sudo will even work now. Move. I usually move so that the old one is not here, and I put it in user local bin. See how sudo works? Now we're going to be running that one. Tor thread start. Now it's going to take a few minutes to grab connections. Okay, that's the only thing. We're running on the Tor network. Let's see. Oh yeah, here we go. Now we're synchronizing. But I can do this other stuff because it can synchronize in the background. We're already up to 2,521 blocks. And the mainnet has 9,275. So this is a pretty fast, as I mentioned, we're already 2/3 of the way there. So we could actually just see what happens here. It's almost there. Getting blocks. I have all this stuff is the debugging output. So there's so much stuff coming by that I have a lot of debugging on. So 9227 should be done. So when it slows down and all this stuff in the log file, oh, the command I was using is tail -f, which is follow the log file, debug.log in stealthcoin testnet debug. So we're all synced. Now what we want to do is decide the name of the staker. Okay, if you want to run a staker, this part is pretty straightforward. I like, stealth is great. I think that's name. Okay, so I decided that. I didn't even take a command. Okay, so then what I want to do is generate. Oh wait, I'm used to testnet where I'm putting the / in front of everything. Get new address. Okay. And you can actually name it something. My staker. Well, stealth is great staker owner. First owner. There it is. That's an address. Now we have to figure out what the pub key is. Oops. Again. Validate pub key. Validate address. Sorry. Validate. There's a validate pub key command. And I'm validating that one. When I do that, it spits out what this is. And this is the first owner key of Stealth is Great. Now I just send that over to us. You don't, on mainnet, nobody's going to get a staker for you. You've got to do it yourself. And the way you do that is like this. So I'll make a staker right here on this one. Stealth is great. I think it should be a valid one. If it's not, it'll tell me. So I'm going to first send. You got to get some funds. So if it were in RealNet, you'd have to just go buy some Stealth. You can't mine it anymore. Or if you already had some from a long time ago and you were like one of the original people who mined it, and you still had some left over from that, you wouldn't have to buy it. You could beg from your friends or borrow from your friends to give back after your stealth node earned it. It should take a while, or just buy it. So send to address MNF field no so on. Sending to that address, enough for staker. I'm going to be making get staker price. I think that's right. Okay, I'm going to send them over just a little bit more than that. Because it goes up every block. Well, the blocks right now are 20 seconds. So, oh, did we just have a block? Yeah, it just went up. So I could send them that, but I'm just going to send it 16,000. 16 or 1585. You know, I'll give them a little change. It's like a little, you know, because you're friends and stuff. 15860. Okay, now the only thing about this is we're not on quantum proof of stake. So the testnet blocks are 20 seconds, which I can tell is causing just a tiny bit of a problem on testnet. So I may I'm going to keep those, but I may just only have one staking node on testnet, just to keep the forks down. I don't really care. Quantum proof, I mean, regular proof of stake is working fine, so I'm not trying to debug that. It's been working on Stealth since 2014 for 5 years already. Okay, so I think it's actually confirmed. Once again, get transaction. So yeah, it's already had a confirmation. So one confirmation is enough to spend it. So let's spend it. Spend that bad boy. Oops. Stealth. Help. Purchase sticker. It's always a good idea to put help. Otherwise, you have to remember all this stuff. Okay, so now here's what we're going to spend. Okay, this transaction. Look, I remembered not to put the // in front of it. Transaction ID. Oh, which output are we going to spend? Quiz, which output are we going to spend? 0, which only has 1.83, or 1, which has the amount that we were going to, it's 1. Okay, and it's coming to this one. I already noticed because I recognize this little, for some reason that is recognizable to me. FOE, FEO, strange combinations of vowels into. There's also ZAR. I'm taking that as a good sign. Okay, so that's what we're gonna. Oh, so we're gonna spin this one with 15860. Output number 1. All right, that's the hard part. We figured out which transaction we're gonna spend for both the fees and the staker. The one that is it's not where the authority comes from, believe it or not. You specify the authority separately here. I guess I could have taken it from the input, but there's more than one way to spend a stealth transaction, and only a couple of those ways I think is, do you actually get the public key inside the signature? So here we're not going to do that. In this, I just said the owner's just going to have to be made explicitly. So I could have actually sent this to any address. Then alias stealth is great. I'd probably come up with a stronger word than great, but I can't think of one right now that would keep me within the size constraints here, because I think I only get 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's short enough. Okay, and the owner key. What's the owner key? That's right. It's the key that we made. What's happening here? Right, it's the one that corresponds to this address we own. You can always, it might be a good idea to make sure you own it. Stealth, validate, pub key. It's like, do I really actually own this? Oh yeah, I do. Okay, super. Now one thing I forgot to do, is you want to encrypt your wallet. So I totally kind of blew it here. I'm generating pub keys and stuff, and my wallet's not encrypted. I'm going to put this in the written instructions. Be sure to follow those. But what you want to do actually, I'm going to construct this command, but I'm not going to enter it. So I'm just going to do it with an echo. Echo is great. Okay, so I do own this key. Before I go too far, you want to do this before you go too far. I mean, in principle, you do it right away, but it's like on your first session. So I didn't really actually blow it. So if you put it out of order like this and you're just remembering to encrypt your wallet, it's fine. Okay, so I'm just echoing that command. So now that's in my history. So what I want to do is stealth encrypt wallet. And I got to do the passphrase. So the passphrase is, I'm just going to make a random passphrase. That one wasn't very random. I have a random passphrase generator. I want it to look random, you know, not necessarily. I got a passphrase generator over here. I'm editing it. Okay, this is not the greatest passphrase in the world, but it is random. You may want it to be something you can remember, of course, or write it down or something. This is a little short. It's 10. 10 is a little short. And it has a bunch of T's in it, but whatever. It's still random. So what happened? Okay, now you want to back that baby up. Now look, here's a quiz. Do you back it up on the server that you're using? No, you go to your local machine where you're running Time Machine or some other backup service, or you put it in the cloud. You know, let's pretend, you know, I have Dropbox on this computer. It's encrypted with something with way more than just 10 characters. Okay, so SCP-T3. It's not actually. Yeah. Root at. Are y'all tired of me saying root? And then .stealth coin test net wallet.dat, and then you can back it up in Dropbox. That's not really what I recommend doing. I don't back mine up in Dropbox. I back mine up in a separate directory. It gets backed up with Time Machine because I use Macs. I also put those wallets on an SVN server on a virtual private machine, private server that I have running. That's a high kind of a dedicated. Well, no, it's dedicated server with dedicated hosting somewhere, and it's backed up there. And then I back up my wallets on all my different computers I use. So there's a copy of every wallet. There's dozens of copies of every wallet I have. Okay, because the worst feeling is losing money. Well, one of the worst feelings. Okay, so and now I'm in my Dropbox directory. I don't really have Dropbox running on Testnet Node 3, but just let's pretend we're there. And what I usually do is I usually date. I'm just going to see make sure I get the date right. So today's is September 13th, and wallet dot 20190913.dat, and then that's on the, remember. Okay, so now what I do here is I actually check it with this with MD5 or SHA. MD5 is the old one, but it's good enough for this because you just want to make sure they're the same without doing. This is how you do a byte per byte comparison. Is MD5. If you're security minded, use SHA 512 some, and it makes a lot longer stream. But that's like if you're downloading a wallet program from the internet or something and security is paramount, you'll use that big long one right there. MD5 is good enough. You just look at first few bytes, last few bytes to check that you're copying fine. That's good enough. So, and then I'm going to MD5 some dot SSH, dot stealth testnet wallet.dat, and it should be EOD3 EOD. So the one I copied, the copy EOD3 4D3, and the one that's there EOD3. So we're ready to start stealth. Yeah, wow. You know what I'm gonna do? I'm gonna write down. Writing down a passphrase is good. I know this is just testnet, but I don't. But it is a staker. You know, I'm making I'm going to make an asset right now, so I just need to find something to write down on. I have a passphrase book that I use, but I don't want to. Since it's testnet staker, I'm going to just T2. I don't typically encrypt testnet wallets. YTQ, because they don't really represent any real money or anything. But I'm writing this one down. That's what I'm doing. And then testnet 5 wallet staker. Okay, there we go. I will assign that staker a key, but just in case, like, my computer crashes and I'm like, oh my god, what was that password? I just lost a staker to the abyss. I wouldn't even be able to disable it, right, if it got enabled. So now I have a backup of the wallet, which is good. Okay, so we got to run it, and I'll be doing that a lot. Okay, so now it's running. It's got we got a list of transactions. Stealth list transactions should be up by now. It does have a little boot up period. So there it is. So I echoed way up here. Let me see if I can find that bad boy. It's gonna ask me for my wallet passphrase here. Stealth coin D, well, we have to tell it what we want to do, don't we? Stealth coin D, purchase staker. Without a command, it has no idea why you're putting all this stuff in here. It's a computer. They did a study. I think it came out of Johns Hopkins. Or no, it was MIT. It was technical. So was MIT. And they found computers to have absolutely no mind reading capacity. Like, computers couldn't read your mind at all. Okay, now it's going to tell me my wallet needs to be unlocked. Stealth coin, wallet passphrase. Man, I sure am glad for security purposes that I encrypted my wallet and I backed it up. That's just great habits. Okay, now you got to tell it what you want it to do. So you type in the wallet the way this command goes is stealthcoin D wallet passphrase, then the passphrase. I hear in clear text, so make sure nobody's standing behind you. And then the number of seconds you want it unlocked. I usually put 4 nines. Bang, and it's all good. Now check it out. Now I can purchase a staker. There it is. Now this is going to take a couple of minutes, not a couple of minutes. It's going to take 20 seconds or something. Get transaction. Zero confirmations. So we got to wait. Oh, I think a block just came in. One confirmation. So now we should see stealth is great. It didn't complain about stealth is great, the name. Remember I put stealth is great somewhere. Okay, but now we can do stealth, get QPoS info. Stealth is great. Qualified true, enabled false. The last thing I'm going to do for this demonstration is enable the staker. Okay, so let's see how fast we can do it. Now, the change for the staker went to our address, I think. Yes, see, check it out. It went to our the change for the staker purchase, which was 2.27, went to this address. So we can just use this guy. We can use this transaction. So first, stealth, get transaction. There's the transaction. Stealth, this is what we're going to spend. Remember HEO, that sticks out to me. Also ZAR in the middle. So you can memorize some things, or I can at least. I always like to remind myself of that. Stealth, validate address. You don't have to do this if, I mean, that's, I guess we don't even actually have to do that. We just have to know the transaction. So, and the name of the stealth is great. So let's just list that transaction again so we can have it right there. So stealth, CoinD help, enable staker. This one I actually have memorized because there's only 3 things. And these 2 are repeated everywhere, so it's like, it's hard to forget this one. Okay, stealth, enable staker. What transaction? The ones that says we have the authority. Remember, because the authority we gave was for this address that has ZAR in the middle and this EO at the end. So that's here in this output. So that's that transaction ID in the first output. So we need the transaction ID. That was this one. Pasted. The first output, that's triple checking and stuff. So V out. See, V out is here. This doesn't have anything. That was a stake. Okay, we'll forget that one. Here we go. V out is 1. This was the purchase, not a stake. It had a V out of 0. Purchases are not spendable. To make them spendable would have been a little hassle, coding wise, and not necessarily. So on a purchase, which is only going to happen maybe 100 times in the lifetime of a blockchain, this extra little output here, I've made that sacrifice. Okay, so over the millions, hundreds of millions of blocks that are going to be on this and transactions, there would be 100 additional outputs here. Worthy sacrifice to avoid all that unnecessary code. So here's where the money is, 1. Okay, so let's get this guy spent before it gets staked. And what staker does all this belong to? Stealth is great. Where's stealth is great? Well, I just remember. Oh, I'm just going to, so the real name is this. But just for the purposes of demonstration, I mean, I'm going to make this window just a touch bigger so it will wrap correctly. I can type it in all lowercase. Okay, just because I can't have all caps stealth is great. You can't have all lowercase. That would be way too confusing. So the protocol considers them equally except when it's representing them. Like up here whenever I did get QPoS info. Okay, so there's a transaction. So that's an enabled staker now. That doesn't do anything because we're still in the proof of stake phase of the testnet. But now we can just get QPoS info. So notice I did put it in lowercase. I'm the type of person, you know, I have a rigid personality and stuff. I'll actually type it uppercase as it is supposed to be and lowercase, just write but it's not necessary. Sometimes I actually violate those kind of rules too and get sloppy, but you know. Okay, so here it is. Is it enabled? Yes. Was it enabled before? Well, if I can find it with the scroll up, I did find it. It was not enabled. So that transaction has actually been confirmed as far as this node is concerned. And we've enabled a staker. And we can just look at the form of that. It's gonna this would give me an error, so I'm not gonna hit enter because I've already spent this transaction. Just looking at the form of that, help enable staker. The transaction ID that's going to serve as the fees, the vout, the output of that transaction that has the fees, that also has the address, that also has the money that was sent to the address, that corresponds to the public key, that corresponds to the staker owner that we're proving by spending this transaction output. That's there. And then, of course, a reference to the staker we want. Do we use names? Yeah. Are we using ID numbers? No, that's just going to be horrible. I mean, this is enough, right? I mean, is this enough? You know, random numbers and letters to look at? I think it is. And so we're using aliases for stakers. They personalize them. You know, you can feel good about your staker. Give it a name that reflects your personality. Okay, that was it. If you've gotten this far, you know, and you have you can do all this, you're going to be able to run a staker, especially if you can send a transaction to yourself. Look up the transaction ID, right? We'll go back. Look up the transaction ID. Figure out the pub key, figure out the address to the pub key with the validate pub key command. Send something to that address. Usually what you do is you do get staker info. You find the owner or whoever has authority for the particular command. We're waiting on that hard drive to spin up. I must have started this shell from a directory where that hard drive is. Okay. In that hard drive directory. Okay, so stealth. So you go here, my owner is this, or let's just say that the owner of it has the authority, or the delegate is to enable or disable. Oh, what is the address? Oh, geez. Well, we have that. We can figure that out. If you're the owner, then you can know what the address is, and then you can just use that. You have that authority, and then because you have that authority, it can. Well, actually, this can go forward. So then you figure out the address, then you send to that address enough for a fee. Unless you're doing a purchase, it has to be enough for a purchase and a fee. And the address goes first. We'll just send one. But 0.01 is an amount for fee, and then that'll send the transaction. Then you reference that transaction. This is the transaction ID that got spit out. So you figure out the this is a review. StealthCoinD, get transaction. There's a transaction. There's the where was that? There was that one output. So that's the address. I remember it. HEOFNL. Oh, I don't want to do this. It was about to copy paste, and let's lose my place here. And ZAR in the middle. Remember that one? So that's the output. Spending authority. Okay. So let's just go back here. Validate pub key. Then we did the send to address, which I've already did. Then we found out that was what the vout was. 0 right here. That specifies this. There's the amount. There's a vout. There's that address. And then this was enable staker. That's all you need. So if the staker were disabled, then I would put in this transaction. I could disable it. I'll just disable it. Hey, why not? The transaction here that we did. The vout Does everybody remember what the V out was? It was 0. V out 0. That's the address. And the staker, you got to put the command. Quiz, does a computer, what did they find at MIT? Computers can't read minds. So you got to tell it what you're doing. That's the command. Don't put that there. Stealth coin D, disable staker, the transaction ID, the output number, and stealth is great, properly capitalized. And now that one will be disabled. We could prove it. We can just look at this transaction just for fun, though. Oops. And if it shows up confirmed, which it might because these blocks are pretty quick, 0 confirmations, we can see that one of these outputs was indeed the non-spendable, 0 value disabled transaction. And all this is the ASM. See, there's the operation we're doing, disabling. Somewhere in this number here is encoded. Yeah, staker. It's got the ID and the op number. I think it's like, I don't know exactly how this is encoded. Pardon me for not knowing how that's encoded. But anyway, the idea is in this right here. The staker number is in here, and also the operation somehow encoded in this. Don't ask me how, please. Okay. We can just do, finally you get QPoS info. Did we enable it? Did I disable before? Oh, I disabled. I meant to enable. Oh yeah, I meant to disable. So there it is. It's to say it's not enabled. Okay, well, be sure to read up on the tutorial, the written tutorial I'm going to submit with this video. I know it was long, but it may save you some time, some head scratching. You got some concepts. You watched proof of stake blocks roll by, and we will see you in Telegram, on Twitter, and anybody who needs help, I will be there to ask the community, and hopefully we can find some more consensus issues and make this thing really work well. Testnet will start in less than 4 days by the time this is published, probably less, about 3 days whenever this actually goes out and I have a chance to do the written instructions and the blog post. Okay, everyone, have a good weekend.